This unit is about optics. In this video, I'm going to give you a basic introduction to the ideas. We're going to talk about some properties of light and of what we're going to be doing with optics, and defining some important terms that we're going to use later. Let's get started. Optics is the study of light and devices that use light. Now, we know that light travels in straight lines. Actually, that's a half-truth. There are some things that happen when it doesn't travel in straight lines. I mean, we're going to be talking about, in particular, what happens at a surface. But actually, light is also bent by gravity. Now, that's relativity. We'll talk about that much later. Light travels in straight lines, but what happens when it meets a surface? Well, it might be absorbed. No more light comes out. It might be reflected back at you. It might pass straight through into the new material. And of course, what happens in practice is usually some combination of these things. And in this unit in optics, we're going to be studying all of these things. Where does the light come from? Well, there are luminous bodies. These produce or give off their own light. The sun is luminous. In fact, the sun is incandescent. It gives off light because it's hot. Actually, your stove is probably also incandescent. When you turn it on to the hot setting, it will probably start glowing a red. If you heat metal enough, it gets yellow, even white. Of course, you might have a gas stove, but a gas stove is, again, the gas is glowing because it's hot, which means the gas is incandescent. In contrast to luminous bodies that give off their own light, there are illuminated bodies. Illuminated bodies reflect light from other sources. They can't produce that light themselves. For example, if the sun is luminous, the moon, in contrast, is only illuminated. The moon doesn't produce its own light. It just reflects light from the sun. An illuminated body can only be a source of light if there's some other luminous body around to illuminate it. When we study what happens to light, we're going to be drawing ray diagrams. We know light travels in straight lines. So if you're standing here, you can see the cat and you can see the dog, because the light can travel in a straight line from the dog's face to your eyes, from the cat to your eyes. But you can't see this. I don't even know what that is. You can't see this because it's behind you. The light travelling in straight lines can't get into your eyes. You can't see this flower here because the light travelling in straight lines can't get into your eyes. So we're going to be drawing ray diagrams to work out what happens to the light as it leaves a luminous or illuminated body and travels to your eyes. That's what we're going to be studying. We have to remember that our ray diagrams are only a representation. They're a model to help us figure out exactly what's going on. Another term we're going to need to know is the normal. The thing is, when we want to know what happens when a light ray comes to a surface, we actually always want to measure the angle between the light ray coming in and what's called the normal, a perpendicular line, perpendicular to the surface. This is the angle that we're always measuring. We're always measuring the angle with respect to the normal, never the angle to the surface. You'll have to read questions very carefully. If the question talks about the angle to the surface, remember to turn it into the angle from the normal before you do any calculations with it. And we're also going to be asking what happens to the image of an object, for example, in a mirror or a lens. there are some words we use to describe the image. A real image occurs where light rays actually intersect. If you put a screen there, you will actually see the image on the screen. That makes it a real image. A virtual image is where light rays seem to be coming from, but you can't actually put a screen there and see the image on the screen because the light rays themselves aren't actually travelling through that point. Now, this distinction will become clearer once we start drawing some ray diagrams. An image might also be upright, inverted, or laterally inverted. Now, the first two you probably understand. Upright is the right way up, inverted is upside down. There's also laterally inverted. Now, laterally inverted, when you look in a mirror, you see, and if you look in a mirror and you wave your right hand, the person in the mirror waves their left hand back at you. That's lateral inversion. What you are doing on one side is done by the person in the mirror on the opposite side. That's lateral inversion.